I've been running this test for a couple of days, solar panels in higher voltage or lower voltage, and this is the conclusion that I've reached. When I was running them in series, 48 volt, I lost efficiency, as you can see in this video. At 65 volt, 473, 472, all of them. So I'm getting actually less load this way if I hook them up in series than I would get if I keep them in parallel. And in parallel is a lot more modular. So the higher the voltage that I was going, more efficiency I was losing on this wattage over here. But the wattage over here was definitely lower. Now, if you run thick cables, and I have two 8 gauges coming in here, they could handle 50 amps easy. And there's a short distance to the panels. I've decided that if I run them at 24 volt in MPPT mode at 35, 36, 34, then I get the maximum wattage out of them. Now, ideally, you want to run them at high voltage. But if you run them at high voltage, you need less thicker cables, so there's some advantages. The problem is that you're also dealing with the higher voltage, so if you touch something, you could get hurt, where right now in the 20-something volts, that's not going to happen. But that's not really the point. The point is that they are more efficient when they convert power from, in MPPT mode, from higher voltage or lower voltage for the batteries, which are 24 volt. You do lose efficiency, and it translates into a lot more from higher voltage to 24 than from closer to 24 to 24. Therefore, in this MPPT format right now, they're pushing 550, where before, in any other configuration that I hooked them up, they were way under 500. And here in Vegas, the sun and everything else is very, very constant, so I don't have clouds in the sky to affect my data. So yes, if you have a chance and you could run thick cables and you don't have long distances, running them on an MPPT controller is recommended versus PMW. But the lower the voltage, the closer you could bring them to your batteries, the more amps you push into the wires without any losses, the better efficiency you're gonna get instead of converting very, very high voltage to the battery power. So if I'll have to choose between one and the other, obviously I've chosen this, but I could always change them. That's the nice thing about an MPPT controller. You could always change them, where when you have a PWM controller, you can change them. So right now this one is pegging at 27 volts, 5.6 amps, 150 watts, and that's all it can do. It cannot vary it. You cannot play with the solar panels. You can't change their configuration or anything like that. So these are the advantages of having an MPPT controller, is that you could change it, if the conditions change, and you could get better at different voltages of wattage, why not? But it seems that so it's still worth to have an MPPT, because I'm same solar panels, I'm running them at 35 volts instead of 27 volts, and the amps are very, very similar, so I'm getting more out of them. But at the same time, this seems to be better. And also, if I have a little bit of a shade compared to the high voltage, if I have a little bit of a shade from a chimney or something like that on one of my solar panels, the other ones are still pushing when you run them at lower voltage, where when you run them at high voltage, the entire string goes down. So there are some advantages, and the cables were not that expensive. I ran 2 just for the hell of it. Initially, I wanted to just have 1, but now I ran 2, and I'm very happy with that. So this works. Thanks for watching.